Assalamualaikum dan salam sejahtera to all my students. Okay, today we are going to continue our lesson, chapter 3, Oxidation and Reduction, part 2. Okay, so there are many redox reactions in our daily life. For example, combustion, extraction of metal, corrosion of metal, and electrochemistry. So we have learned during Form 4 for extraction of metal, corrosion of metal, and electrochemistry in chapter 6. So actually there are redox reaction, but we still did not touch in terms of redox. Okay, so our focus in redox reaction are 5 chemical reactions. Okay, ada banyak redox reaction in world, but kita cuma fokus pada 5 chemical reaction saja untuk this topic. Okay, so the first two is the displacement of metal from its salt solution, and the second one is the displacement of halogen from its halide solution. This reaction also you have learned during Form 4 in chapter 6. So now we have to know how to explain this reaction in terms of redox. Another 3 reaction, the change of ion 2 ions to ion 3 ions, and vice versa, will be taught in the next lesson. The same goes for the 5th reaction, the transfer of electron at a distance. Also akan diajar dalam kelas seterusnya. Okay, so now we proceed to our next slide. Okay, so displacement of metal from its salt solution. Okay, penyesaran logam daripada larutan garamnya. Okay, in Malay. Okay, so this is the reaction. So the reactant must be metal and salt solution. So this one is metal, logam. So we dip or we immerse in salt solution. Okay, this one warna biru ni, blue solution is a copper sulfate solution ataupun copper nitrate. Okay, so kita tengok macam mana redox ni berlaku dalam displacement of metal. Okay, so displacement of metal is a process where the more electropositive metal, which is located higher in electrochemical series, is able to displace a less electropositive metal from its salt solution. Okay, so metal which is more electropositive, ni contohnya ni, okay, sodium, potassium, magnesium, which is located higher in electrochemical series. Tengok higher bermakna kedudukan yang atas. Okay, is able to displace, mampu untuk menyesarkan metal yang kurang elektropositif yang berada dalam keadaan larutan. Okay, larutan adalah larutan garam. So dalam larutan garam, salt solution, for example, potassium chloride, sodium chloride, magnesium chloride, and so many salt solution lagi. Okay, dalam semua salt solution ada metal. So metal ni biasa kat depan cation, cation. So for the first case, for example, potassium chloride, KCl. So dalam ni ada K plus ion. Okay, NaCl. Ada Na plus ion. Magnesium chloride, Mg2 plus ion. Okay, so ini adalah metal, but dia berada dalam bentuk solution. So now kita nak displace dia, nak jadikan dia dalam bentuk metal atom. Okay, so in order to displace this ion to become metal, we must use a more electropositive metal. Okay, ni. So ingat, metal yang kita nak guna untuk displace metal dalam salt ni must be more electropositive, mesti berada lagi tinggi daripada metal yang berada dalam salt solution. Okay, so you have to remember lah the electrochemical series. So you tengok sini dia cakap the tendency to donate electron decreases, bermakna lagi atas dia lagi senang untuk donate electron, easier to donate, meaning kalau dia easy to donate bermakna dia lagi senang untuk hilang elektron, lost electron. Bermakna metal atas ni, okay, metal ni akan mengalami proses oxidation. Kenapa oxidation? Because dia akan donate electron. Okay, manakala metal yang dalam salt solution ni akan gain electron daripada metal yang atas tadi, okay, ion metals dalam salt solution contohnya K plus akan gain electron to form metal. Okay, kita akan tengok example for clearer explanation. Okay, so for example, okay, this is the reaction between magnesium straight in copper to sulfate solution. Okay, ni magnesium straight maknanya magnesium metal lah. Okay, ataupun magnesium plate immersed in copper sulfate ataupun reacts with copper sulfate solution is a salt solution. So dalam ni ada Cu ion. So kita nak display Cu ion ni jadi Cu metal by using magnesium metal. So kat sini boleh berlaku reaction lah kan, because magnesium is located above than Cu in ECS. So magnesium is more electropositive, thus it can displace Cu ion from its salt solution to become Cu metal. Okay, so the first step we must write the chemical equation. So chemical equation between the metal, which is Mg, reacts with the second reactant, copper sulfate. So the product is, okay, this one you must know lah how to write the chemical equation. Okay, so after dapat chemical equation, after the reaction, okay, Mg metal ni akan jadi Mg sulfate. So daripada metal Mg metal atom, dia jadi Mg2 plus ion. Bermakna dia dah oxidize, dia dah lose electron. Okay, manakala copper sulfate daripada Cu2 plus ini, dalam ni Cu2 plus, because dalam ni is a salt solution, Cu2 plus and sulfate SO4 2 minus, right? Jadi Cu2 plus after reaction becomes Cu metal. Jadi Cu oxidation number dah berubah from plus 2 jadi kosong. Jadi dia dah reduction process ataupun Cu2 plus gain 2 electron to produce Cu metal. Okay, the process is reduction. So daripada sini you dah nampak dah dia punya redox. Okay, so now kita nak explain one by one. Okay, so magnesium is more electropositive than copper in the electrochemical series, or we can say magnesium is located higher than copper in electrochemical series. So the same meaning, you can use either one lah. Okay, so what we can say, magnesium will undergo oxidation, which is dia akan hilang elektron, akan donate elektron. Daripada Mg metal tadi, donate 2 electron to form Mg2 plus. Okay, so now kita akan describe the first reaction, which is oxidation dahulu. So dah tahu dah siapa akan melalui oxidation, which is Mg, right? Okay, so from the chemical equation, we convert into half equation. So from Mg, after the reaction become Mg2 plus. From here Mg2 plus 2 electron. Why plus 2 electron? Because it undergoes oxidation where it must lose 2 electron. So in other words, we can describe magnesium atom will oxidize or lose electron to form magnesium ions. Ini very important, from atom become ion. Okay, whereas for observation, okay, so since daripada metal dia dissolve jadi ion, bermakna Mg metal ni nanti akan become thinner. At the end of the reaction, mungkin Mg ni akan dissolve completely, tak nampak dah, dia akan dissolve jadi Mg2 plus ion semua. Okay, so kat sini we can say copper sulfate will act as oxidizing agent. This one akan jadi agent pengoksidaan untuk Mg ni. Okay, so done for oxidation. Next we explain for the second reactant, which is copper sulfate. Okay, so the process is reduction. Of course lah, automatically tadi dah oxidation, another one must undergo reduction. So from Cu2 plus, why Cu2 plus? Because dalam copper sulfate solution ada Cu2 plus, after the reaction become Cu metal. Okay, become Cu. Okay, plus 2E. Why plus 2E di sini? Because sekarang reduction is a gain electron. Gain electron sebelah sini lah, lose tadi sebelah sana kan, donate. Ni gain. Okay, so in other words, we can say copper 2 ions gain electron to form copper atom, ataupun copper 2 ion is reduced to form copper metal. So the observation, Okey, dalam ni tadi awak warna biru, right? Warna biru tu adalah disebabkan oleh Cu2 plus ion. At the end of the reaction, dia jadi copper metal. So copper metal kita dah belajar dah, dia punya color is the brown solid is formed. So the in front is copper atom is formed. Okay, so di sini we can say magnesium will act as a reducing agent. Okay, so observation of the solution, biasa dia akan tanya observation of the solution, especially when we use the color solution just such as copper sulfate. So we can say the intensity of the blue copper become decrease. Keamatan warna biru ni akan semakin pudar. Kenapa makin pudar? Because yang menyebabkan warna biru adalah Cu2 plus ion. Cu2 plus ion di sini telah di reduce ataupun telah dinyahcas. Kalau kita belajar elektrolisis dulu, dinyahcas dengan menerima elektron untuk menghasilkan copper. Okey, dia akan jadi macam ni. Okey, ni. Awal-awal dia biru dia terang, after end of the reaction dah tak ada lagi warna biru, semua dah jadi warna colorless. Kenapa? Cu2 plus ion yang menyebabkan warna biru ni sudah dinyahcas ataupun telah di reduce menjadi Cu metal. Cu metal warna brown ni. Pada kepingan besi metal Mg tadi akan ada copper atom yang berwarna perak. Okay, alright. Okay, so kalau masuk exam, dia suruh describe the reaction in terms of redox, gain of electron ataupun change in oxidation number. Dua-dua kita boleh guna dari dua segi untuk reaction ni. Dua-dua boleh guna in terms of transfer of electron ataupun change of oxidation number. Kita boleh describe dua-dua terms. Okay, dia boleh jadi 10 markah. Okay, in essay. So you must write every ni lah, chemical equation, explanation, then describe oxidation, dia punya 4 points ni, reduction dia ada 4 points juga. Okay, in short, okay, or we can use the table. Cikgu nak you buat jawab task lepas ni guna this table. Okay, buat satu kolom oxidation, buat satu kolom reduction, then ada dia punya item-item, chemical equation, explanation, half equation, explanation. Okay, you can copy this one. Okay, so the first task is example 2, 3 and 4 in your module page 109 and 110. Okay, so you use the same template, use this one table. Okay, so now we move to the second reaction, which is the displacement of halide by halogen in your module page 110 and 11 until 112. Okay, so actually displacement of halide also you have learned during your form 4. Okay, so kita terus tengok example. Okay, this is the example of the reaction. Okay, so between chlorine water, which is the halogen, and the potassium bromide, which is the halide. Satu reaktan dia halogen, satu lagi halide. So contoh-contoh halogen is the element in group 17. Contohnya fluorine, chlorine, bromine, iodine and acetylene. Okay, so have color in the aqueous solution. So this one, dia orang ni memang berwarna. Kita belajar masa form 4 dulu kan. Okay, manakala halide, halide ni adalah salt or compound that is consist halogen. Dalamnya ada halogen dan all halides are colorless. Halide ni adalah garam, sejenis garam juga, ataupun compound yang mengandungi halogen. Contohnya potassium fluoride. Jadi dalam ni ada fluoride. Fluoride asalnya fluorine. Okey, dan dia berwarna kalau fluorine dia berwarna kuning, kalau tak silap yellow. Okey, tapi kalau dia bentuk garam halide, dia tak ada color. Semua ni warna colorless. Okey, for chlorine, halogen chlorine dalam garam dia akan jadi chloride. Contohnya sodium chloride. Dalam ni chloride juga colorless. Garam kat rumah ni color garam kat rumah warna putih, white. Okay, white solid. Next is bromine. Bromine is warna brown. Okay, bromine brown. Okay, so in halide we call it as bromide or potassium bromide, sodium bromide. Okay, lithium bromide. Okay, next is iodine. In halide known as iodide or potassium iodide, sodium iodide, lithium iodide, iodide salt. Okay, so dia cakap dia punya prinsip, a more reactive halogen can displace a less reactive halogen from its source solution. So kat sini, halogen must be more electropositive than halide in the salt ataupun aqueous solution. Jadi kat sini nak tahu mana lagi reaktif, mana lagi less reaktif, kita tengoklah dia punya the position, the location, dia punya location in periodic table. So fluorine atas sekali, lepas tu chlorine, bromine, iodine kan going down the group. Jadi yang paling reaktif sekali adalah fluorine atas sekali. Jadi fluorine ni boleh displace semua garam-garam halide. Manakala the least reactive is iodine. Iodine ni tak boleh buat apa-apa, tak boleh nak displace fluoride, tak boleh nak displace chloride, tak boleh nak displace bromide, because dia paling kurang reaktif. Okay, so now kita tengok example. Okay, ni cikgu cakap tadi. Okay, so halogennya adalah chlorine, bromine, iodine. Okay, fluorine biasa jarang dia guna because dia tak practical, dia very reactive and very dangerous. Okay, so chlorine, jadi kita guna halogen chlorine. Halide salt dia adalah potassium chloride, potassium bromide, potassium iodide. So for potassium chloride tak ada reaction lah because the same, right? Chlorine dengan chloride. Okay, for potassium bromide, so dia tick tanda kan, boleh berlaku reaction because the chlorine is more reactive than bromine. So it can displace bromide from its salt solution to becomes bromine gas. Okay, for iodine, okay, you can see the table lah. Okay, for iodine, cikgu ambil satu example. Okay, kita guna halogen dia, iodine. So sini contoh iodine water reacts dengan potassium chloride. Ni potassium chloride. So dia pangkah, tak boleh berlaku reaction. Kenapa tak boleh berlaku reaction? Because iodine is less reactive than chlorine. Okay, jadi dia tak boleh displace chloride from its halide solution to become chlorine gas. Okay, kita tengok reaction. Okay, so dia cakap chlorine was added to potassium bromide. So the reaction is between chlorine water and potassium bromide. The halide potassium bromide, the halogen is chlorine. So kita buatlah chemical equation. So chemical equation for chlorine is Cl2 reacts with KBr, potassium bromide. Okay, the product is potassium chloride plus bromine water. Okay, so you pecahkan dia punya anion, dia punya ion. Sini akan ada K plus dengan Br minus kan. Jadi K plus akan pergi ambil Cl minus to form KCl. Another Br left here akan jadi Br2 bromine molecule. Okay, so we can say chlorine is more reactive than bromine because chlorine is located higher than bromine in group, right? Jadi chlorine will displace bromide. Bromide dalam potassium bromide ni. Okay, akan displace bromide ion from its salt solution to become bromine. So kat sini chlorine will act sebagai oxidizing agent, ataupun we can say it undergoes reduction. Ingat, dia bertindak sebagai oxidizing agent tapi dia akan menjalani proses reduction. Okay, so now kita akan go for the first reaction, which is oxidation. Bermakna kalau chlorine undergo reduction, yang mengalami oxidation adalah satu lagi, iaitu KBr. Okay, so daripada equation KBr, dia ambil Br minus bromide ion. So kat sini kita cuma concern dia punya halide. Okay, kenapa kita tak concern potassium? Because yang memberikan indikator reaction warna perubahan adalah warna halogen ataupun halide ni. Okay, kalau potassium, kalau you tengok pun, okay, sebelum reaction dia adalah K plus, right? Dalam KBr ni kan, dia K plus ion. After reaction, dia jadi KCl. Still K plus. Jadi no change in oxidation number. No change in terms of electron transfer. So dia tidak berlaku redox. That's why kita ambil Br minus. So Br minus before the reaction, after the reaction becomes Br2. Okay, so kita balancekan equation, akan dapat 2 Br. Okay, sini 2 Br minus. So elektron kenapa duduk belah sini? Ingat, sekarang ini adalah proses oxidation. So oxidation is the loss of electron. Jadi plus 2E. Kenapa 2E? Because charge dia 2 darab dengan negatif. Okay, so kat sini we can say bromide ion. Bromide ion sini daripada KBr ni will oxidize ataupun akan lose electron to form bromine molecule Br2. Okey, bromide ion jadi bromine molecule. So, observation. Okey, tadi tengok dalam ni KBr tadi dia adalah halide. Halide is a colorless solution will turns brown solution. So, bromine tadi halogen ada color kan, warna brown. So, itulah dia punya perubahan. So, kena tengok equation, boleh tahu dia punya observation sekali. So, from colorless solution turns into brown solution. Macam ni dah lebih kurang. Okay. So, kat sini dia punya another one reactant which is chlorine water akan react as a oxidizing agent. Okay, next. For the reduction process. Okay, so tadi KBr dah undergoes oxidation, bermakna the reduction process chlorine water lah. Okay, so Cl2 after the reaction become Cl minus. Kenapa Cl minus? Kat sini K plus dengan Cl minus kan, ion kan. Okay, so sama juga. Okay, Cl2 become Cl minus. So kita balance equation. Sini ada 2 Cl, jadi letak 2 sini, dah jadi 2 negatif dia punya charge. Jadi elektron kena letak sebelah sini. Why? Because sekarang reduction process gain electron. So dia gain 2 electron. Kenapa 2 electron? Because 2 times negatif ke atas ni. So 2 electron. So we can say in other word, chlorine gains electron to form chloride ion, or chlorine is reduced to form chloride ion. So observation tengok. Okay, chlorine Cl2 is a halogen. So halogen ada color kan. So biasanya warna yellow. After reaction it becomes halide solution. So halide tak ada color to become colorless solution. Very easy, right? Okay, so di sini KBr will act as a reducing agent. Okay. So the conclusion is we can say bromine is displaced from its salt solution which is KBr by chlorine water. Okay, bromine yang ada dalam KBr ni boleh disesarkan menjadi bromine gas dengan menggunakan halogen yang lagi reaktif daripada bromine. Okay. Okay, some additional information you must know in page 112 in your module, the color of the halogen in aqueous and in indicator. Okay, indicator dia guna biasanya 111 trichloroethane. So kalau chlorine, color dia dalam aqueous biasa dia warna pale yellow. Dia nak test, after the reaction kita nak test the presence of the chlorine, kita letak dalam 111 trichloroethane. Dia akan produce warna colorless ataupun pale yellow, lebih kurang macam ni. Manakala bromine, okay, dalam aqueous biasa dia warna brown. Dalam 111 trichloroethane dia warna brown juga, lebih kurang ginilah perang. Okay, iodine, okay, dalam aqueous biasa dia adalah reddish brown. Okay, where we put 111 trichloroethane dia akan jadi warna purple. Ni untuk detect the iodine. Okay, this one purple macam ni. So boleh tengok macam mana dia punya two layer of form when aqueous solution of halogen is mixed. Okay, gini. Bawah ni dia punya solution 111 dia kan takkan bercampur. Okey, dan atas ni kita boleh tengok dia punya color yang terhasil. Kalau warna purple bermakna itu adalah iodine. Kalau warna brown itu adalah bromine. Kalau warna yellow ataupun colorless dia adalah chlorine. Okey, so for this reaction tadi, dia after the reaction dia produce bromine kan. So dia punya observation nanti kalau letak 111 trichloroethane dia akan produce warna purple macam ni. Okay, kita kena tengok after the reaction. Jangan tengok belah sini. Tengok after reaction dia produce apa. Okay. Okay, so sama juga buat table macam tadi juga, macam yang metal juga. So kat sini ada halogen, kat sini ada salt. Jadi bila kita guna iodine as a halogen, dia tak boleh displace chloride, tak boleh displace bromide, tak boleh displace iodine. Dia because dia less reactive than chlorine, bromine and iodine. Jadi it cannot displace the chloride, bromide and iodine. But for chlorine, dia mampu, dia is able to displace any halide salt. Okay, because chlorine lagi reaktif than bromine and iodine. That's why boleh berlakunya reaction. Macam ni lah. Okay, so this is the second task in your book, Modul Alkimia, page 112, example 1, 2 and 3. So cikgu nak you explain menggunakan point seperti ini. Okay, ataupun you can write the table. Okay, it's up to you. Alright, thank you. That's all for today. See you after this.